Our next speaker, he's Batman's friend. His name is Beardman, actually. Marc Stearman from Lawrence Livermore National Laboratory. Marc Stearman is a battle-hardened veteran of Lustre wars gone by. Still has nightmares of routed file systems configured in XML. He dreams and hopes to retire one day in a utopian society where vast parallel file systems live in stable colonies. The tears coming to my eye, with large capacity fountains which are overflowing with bandwidth, with not a single bug nor pest buried deep within the code. I'd like to present to you a man of our time, my own personal hero, Marc Stearman.
Thank you, sir. Thank you. Thank you. I had to try and top last year's bio. I don't know if that did it or not, but... All right, so this talk's going to cover a lot of different things. It's a little roundabout, but it's a lot of, what our philosophies are at Livermore, how we view file systems, how we think they should be managed. A little bit of background on how many of them we have, what we're doing to monitor them, and a little bit about the data movement. Last year I talked about moving data off of Sequoia's file system onto the open side before we swung it over. So there'll be a little bit of a follow-up on that, and then kind of what we're doing next. Some people say a philosophy is the love of wisdom. That's one way to define it. Doing things right for your users, even though it may not be the way you wanted to do it, is one of the things we've had to learn this year. 4 years ago, 5 years ago, if you had asked me, globally founded file systems were the way to go, right? We were writing XML code to, globally mount them in the 1.4 days. And we continue to globally mount them, although lately things have not been very stable. And slowly over the past few years, little instances of things would cause cascading failures out, and it would cause these ripple effects that would take down file systems due to a small problem on a single node or an IB leaf switch. We have about 100 petabytes worth of storage at Livermore right now. Most of that's on the closed side. We have the Sequoia file system that's 55 petabytes. Another 3 file systems that total about 22, and then we've got 5 on the open side. We're using ZFS compression, which our average ratios are 1.51 to X, or 1.5X. So really it's almost 150 petabytes worth of potential storage that the users could use. And on our file systems, we range from having anywhere from 200 million files to 800 million files, and that keeps growing. They get bigger and bigger. What I mentioned before, a single IB leaf switch internal to a cluster can start doing transmit discards, dropping packets, and that can cascade out and cause problems on all the Lustre file systems that are mounted within that cluster. Eventually makes the metadata servers become unusable to the point where we have to reboot them. So we've really started talking about, can we make smaller islands? Can we reduce the fault domains to smaller, more manageable sets? Originally I'd wanted to mount Sequoia's file system globally, but when you have the number 3 computer in the world, you don't want to mess that up. So it's isolated, it's an island of its own. Network-wise, it's still connected in, but we're just not mounting it anywhere. This is what our network looks like on our secure facility. You can see Sequoia over on the right. I don't know if this laser pointer will work or not, but it has LScratch1 kind of off to itself, max. These orange clusters are visualization clusters. We need viz resources to look at simulation data. But we had a very spread out design. It was a legacy 10 gigabit Ethernet. We had a Cisco Nexus down in the bottom right with LScratch2. That was where Dawn, our BlueGene P system, was attached. We retired that not too long ago, about 6 months, 7 months. This other Cisco Nexus, these are 512 port 10 gig switches. Has Mirror, Juno, Coastal. Those are all about 1,200 nodes each. Zin is a new system that came in. Up here is one of our TLCC2. That one's got about 3,000 nodes in it. We had all these little file systems you see on here, except for LScratch1, mounted everywhere, except Sequoia. It was an island. And we'd have an IB switch in mirror go out, start dropping packets, and that would make every single one of those file systems unusable. From other clusters, not just from Mirror, but Zin, Coastal, Juno, all of them. Unfortunately, these are where all of our paying customers are. These are the people that are paying our salaries, our bills. And they got to the point they were telling us in January that they hadn't gotten any work done for 3 months, which was a bit of a surprise because we knew we were having some stability problems, but we didn't think it was quite that bad. So we simplified things. We dedicated LScratch3 to Zin, made that an island, carved out some nodes we weren't using to make a viz resource. And then we took the other couple clusters, Mirror and Juno, we retired Coastal, got rid of it. Collapsed our file systems. We got rid of all of our LDiskFS file systems, replaced them with ZFS-based file systems, which had more stability, more reliability, and basically made 3 little islands. Stability's improved. This C-Relic cluster here that you'll see, that's basically just a Lustre router cluster. It's got QDR on one side, quad 10 gig E on the other side. C-Slick is our interface to the HPSS archive. So, the other branch of philosophy, if you will, would be the mind-body problem. We have lots of smart minds. We don't have a lot of bodies. That's part of our problem lately. We had a 25% reduction in our sysadmin group due to retirements, people leaving elsewhere. So that makes it a little harder. We haven't reduced our systems that much. The aging hardware that we had was requiring a lot of maintenance. We were failing 20 or 30 drives every week. Sequoia's file system, we lose 4 drives in a month, and that's 24,000 drives. This 20 to 30 every week is also an equivalent, roughly, 25, 30,000 drives. So moving to newer hardware, more reliable hardware is really helping us out a lot. The other problem we had is we had this variety of hardware and software. We had SAS drives, nearline SAS drives. We had LDiskFS file systems, ZFS file systems. We had things that were originally 1.6, formatted to 1.8, formatted to 2.1, formatted to 2.4. That stuff just doesn't work. So a lot of our newer stuff is all running 2.4 and ZFS. So basically that's what we did. We put a plan in place to get rid of all the old hardware, all the old software within a 6-month time frame. That was originally supposed to end in like July. We accelerated that, so it should end probably end of May. Last year this time, we had DDN 9500 systems, we had DDN 9900 systems, we had NetApp E5400 systems. We were running 2.4 with ZFS, 2.4 with LDiskFS, 2.1 with both LDiskFS, right? It's all up there. We had 1.8 clients. Our Dawn system, the BlueJean P, was locked at 1.8. It wouldn't run 2.1. And of course, it was big Indian, so we had Indian issues and lots of FID translation problems. And it was a rough year. So our focus right now is on stability. We want to reduce what we're running in the field, try and get down to 1 hardware platform and 1 software version. Lustre 2.4 with CFS backend. Less variation will allow sysadmins to focus on problems better, reduce the scopes that the developers have to patch and test and work with. Just not having to worry about LDiskFS anymore, makes me sleep better at night. Managing our data is tricky as well. We've used quotas in the past for reporting, not enforcement, but just reporting. A lot of that's been broken lately. There's been a number of bugs that reduce the reliability of it. There's ones that are, you do a quota report and it says a person has like, 1 zillion files, and it's just completely a bogus number, right? So that makes it hard, but Robinhood seems to have more accurate data based on the change logs. We haven't had to purge yet because a lot of these file systems are newer, but We did have a lot of issues getting Robinhood up and running. We worked through a lot of those. It was a little rough ride, but working with CEA, looking at their how-to page, we got some good tunables in there. We weren't able to use it on our 1.8 and 2.1 systems because it just didn't understand the FID thing, and FID to path just wasn't working right. But we are also having a major problem just scanning the file system and keeping up with it. Anytime the schema changes in the database, you have to redo the scan. That's unfortunate. But every time you've got to rescan a file system with 800 million files in it, it's going to take a while. Unfortunately also, those metadata servers are being really hammered because there are major production workhorses. And so everything falls behind. At one point, one of our open file systems was 8 days behind in its Robinhood view of the file system. That's not very useful when you're wanting to purge based on access time. So we're looking at ways we can improve that. If we can do a partial scan, do an S run on 32 nodes, run the partial scans in parallel, try and get the scans to run a little faster. A lot of this is related to just the single client metadata performance. Monitoring is the other important thing. We're putting a lot of value on that right now because how do we know that our users are having problems unless we're really monitoring the file systems and looking at what's going on. Most of our OSS nodes are using NetApp E5400s. It's got a RAID controller in it that does a lot of the health monitoring of the system. But on our metadata servers, we're using just actual dumb JBODs. They don't have any smarts in them. So we're using the SAS to IRSU utility from LSI right now to monitor the state and the status. We use Smart Cuddle. But there's not a lot, right? There's nothing to really monitor the power supplies of the JBODs. So we kind of have to visually inspect those occasionally. The other thing we started using is Splunk. I don't know if you guys have ever heard of Splunk or used it, but it's a nice data aggregation tool. You can throw system logs into it, any sort of text output. You could do database logs, whatever you want. It'll aggregate all that, and then it provides a nice searching interface. So one thing that's hard on us, when the users call and they have a problem, we have to look at the cluster that they were on, the console logs for the node, the syslog that's on that cluster. Then we have to log into the file system, look at all the logs for that. Splunk lets you put it all in one nice single pane of glass. You can get all that correlated. You can narrow it down by time frame and only see what you really want to see. Saves you having to do a whole bunch of greps. You guys don't need to read all those right now, but they're in there for later if you want scenarios. The other thing you can do is use the logger command. Logger command is your friend. It'll throw anything you tell it to into syslog. So you can read in a file like the arcstats file in ZFS, and you can set all of those things to be key value pairs, throw it into Splunk, and then Splunk lets you pull all those fields out and graph it. So we started doing that. Prakash wrote a nice dashboard that you can type in the metadata server host name, and it'll give you a graph of all the values in the arcstats that we care about. So when you're trying to tune your system and see what's going on it, it makes it very useful. These are just some example graphs. On the top, we have a metadata server that's running SAS-based disks. It has an L2 ARC cache device in it. The other one is one of our BlueGene file systems, and it doesn't have an L2 ARC cache device because the whole thing is all SSDs. So the cache device didn't make a lot of sense. But you can see that there's different patterns. You can see different workloads of different user applications. So it helps us really tune and kind of see what's going on in the system. The other thing I've done is thrown IR results data into Splunk. It's something I learned from Lannel a couple months ago, that they will occasionally inject just small IOR runs just to do kind of sanity testing on the file system. So every 4 hours, it kind of rotates between file systems, run on different clusters. It takes 5 minutes. It's not taking away a lot from users. It's a little 32-node IRR job. But you can kind of see on different clusters. Edge up here at the top only has 4 Lustre routers with bonded 10 gig E. So it pretty much caps out at 7.5 gig per second. It's pretty much network bound. It's not going to do much more. Cab is a much bigger cluster. It's got 32 routers on it. So it gets a little bit better bandwidth to the file system that it's hitting. The read rates are still kind of capped, but we've tuned the file system for writing, so that's not overly surprising. These little gaps in here were actually kind of nice to find because one of the nodes that the IRR job was running on had a memory bit error, and the job died. So naturally there's no output printed, so you get a nice blank spot. So it does kind of let you tell over time what your consistency is, whether you're having issues. It just gives you a hint to go back and look at things. Also, I would imagine if we put a new version of Lustre on there that really killed performance, we'd probably see it in the graphs, right? We'd probably see some sort of dip. So knowing what your file systems are doing is useful, and Splunk really helps with that. So last year, I talked about moving a lot of data, how painful it was. We didn't have a lot of parallel tools. So Adam Moody back at Livermore, along with Oak Ridge, Los Alamos, DDN, there were a bunch of people that got together. There's a mailing list out there. The project's called Fileutils. I don't know what that is. So Fileutils, if you go to the website right now, it's not live yet. They haven't really released the package, but you can subscribe to all the mailing lists if you're interested in contributing or seeing what's going on with the project. Basically uses libcircle and MPI so that you can gather a list of all the files you want to copy recursively, and it'll do all these parallel operations. They've got copies, they've got removes. You can do a directory walk. You can do a directory compare of two different directories. It's almost ready for prime time, but it's not quite there yet. But with hand-holding our users, we're happy to help some of the power users move large data sets. Just doing a CP-R of 400,000 files and directories in this tree. The CP-R took about 5 hours. One node dropped that to like 46 minutes, running 16 tasks on the node. If you ran 32 nodes, which had 512 tasks, it got down to about 7 minutes. So there really was a lot of benefit of doing that. Now granted, it does hit your metadata server harder, so we don't want to unleash it into the wild because we don't want the users to just go at it. As such, rsync is still kind of our recommended data movement tool. We know it's slower, but it's a lot more reliable. They can run it multiple times if it gets interrupted. You can always go back and do it. We've told some users you could do it just a CP without any permissions or anything. That'll run pretty fast, and then you can follow it with an rsync to fix up permissions. We've had to concern ourselves with this a lot because we were retiring so many file systems and having the users move their data around so much. In fact, Todd Herr, one of our guys in the data storage group, ran some tests, and he looked at data movement speeds. He had 100,000 1 megabyte files. And we found that the CP-P performance was just atrocious. 19 files a second, right? That's 19 megabytes per second. That's just wrong. But that was a single client, single instance. The next column over to it was the distributed copy tool running 16 tasks on a node, and it did 365 files per second. So much better improvement. The graph on the far right was 2 nodes, right? So it got up to about 500. The other interesting things are HSI. They have a non-HPSS version, so you can copy from file system to file system. Those look promising as well. They do some parallel copies. NFT is one that we like to give to users because it will retry. Right? If you have a failure, it keeps track of its progress and it'll keep going, it'll keep retrying. Problem is it was pretty slow. It was slower than rsync. We figured if users had a really large data set, they'd probably want to run one rsync and then follow it up with another one later if it failed. But we do have all these tools, and we try to give them out to the users when we think it's the right time. So some of our next steps are continue our experiment with islands of storage. I mean, it really is an experiment at the moment. It got so bad that at one point I did the calculation to see if we could take all the file system hardware we had, carve it all up, and make individual file systems per cluster. We didn't have to go that far, but it's an experiment we're looking at. Probably by November at the latest, I think we'll kind of have a decision whether that's our path forward or if we want to try and globally mount things again. ZFS with JBODs is the goal. We've been saying that for years. It's going to keep being a goal. It's not high on the priority list right now for us. We're trying to get things stable, but it is something we would like to have. And we are working on getting the ZIL to be integrated with Lustre. That's something we think is important to get the synchronous writes going to the ZIL instead of to the SAS drives. And then, of course, further tuning, bug fixing. But the ZFS stuff's pretty stable right now. And then, of course, better monitoring, right? If we get rid of RAID controllers, we need to know when the drives fail. The JBODs are just dumb. They don't have any sort of smarts in them, so we really need some software layer to really monitor that stuff. Make the Fileutils released, make them better. And then, we'll explore D&E versus multiple file systems, which one buys you the better thing. But again, that's kind of on the lower priority at this point. We're trying to get things more stable. So, questions? Parks has one.
So going back to the global file system, do you think it's an IB problem versus an LNet problem versus a Lustre problem? I mean, is
Yes.
it just the...
Yes, it is.
Is it just the media, if it was all 10 gig or 40 gig?
I don't think it's purely IB. I think if you had a 10 gig adapter fail or a line board in your switch, you'd probably see similar kind of things. In this instance, we have, you've got 1,200 clients behind a small set of routers, and when that fabric starts to have problems transmitting data at all, then it's almost like you've lost every interface on the inside of your routers, right? I mean, you're just not passing data efficiently. So it could be a different interconnect.
IB routing between subnets would maybe solve that, because then it would be contained within that same subnet?
I don't know, it might make it worse. It's hard. I don't know, Anybody?
Are you running single IB fabrics or dual fabrics?
So these are single rail, all of them. But each cluster has its own internal IB fabric, which could be, most of them are multiple switches in a factory configuration, with 36 port leaf switches scattered throughout. Those all have Lustre routers that then go to a SAN. They either go to the IB SAN or the 10 gig SAN, which are bridged by a set of Lustre routers as well.
There was a previous effort to do the parallel copy tools like MCP and those things. Is this kind of the next generation? And
I think they took John Bringhurst's DCP from Los Alamos and modified it.
And the other questions?
Added in the permissions checking and the things that were lacking in it.
And the second question is, a lot of those applications weren't ever made public because of whatever red tape from DOE type stuff. Right. Is this Fileutils?
Yeah, it's all open source. It's eventually going to be out on GitHub. You can go to the website now and look at it. You could join the mailing list. But yeah, the intent is to have it completely open source and released.
Can I ask about the comparison between ZFS? So you had the compression and LDiskFS in terms of resources utilization.
I'm not sure I understand exactly. We have compression enabled. We're not using any of the other features of ZFS like deduplication or any of that. But.
I mean, you're running on separate servers, Lustre with ZFS and Lustre with LDiskFS. In terms of CPU load or memory consumption, are there many differences, or do they operate like the same?
Sort of. Unfortunately, our LDiskFS hardware is rather old, so it's hard to compare them exactly. Our current boxes, the OSS nodes and the MDS nodes are all Intel Sandy Bridge dual socket 8-core 64 gigs of RAM. They've got the Mellanox IB down on the motherboard. We have the ARC tuned to, I believe, 1/4 of memory. Yeah, I think 1/4 of memory, right? We have been experiencing some OOMs lately where the server just completely runs itself out of memory. So we're looking at that. We've got there's a lot of stats that are in /proc and /sys, so you can see what the SPL layer is doing and see where it's allocating memory, where ZFS is allocating memory. So we're starting to explore that to try and track down where our memory usage is.
Do you have any numbers of how much Robin Hood is performing while you're scanning it per second?
Yes, and I will try and remember them off the top of my head. The question was, do we have an idea of how many numbers of files we're scanning per second using Robinhood? And on a lightly loaded system, I think we're getting close to, I want to say it's like 800 or 900, maybe 1,000. On a heavily loaded system, it drops significantly down to 100 or 200 max, but usually less. Sometimes it's around 50 files per second, right? So it takes a long time. I have exact numbers if you want to catch me after the break.
I think that you need a different solution actually for scanning.
Or scanning in parallel, right? If we were to do the partial scans and run it from multiple nodes, we'd see much better rates. We've done a little bit of that testing, but we haven't implemented that in production yet. But I think that has to be the solution moving forward, because just getting so far behind and not keeping up with the metadata server is causing problems.
I think last year when we were talking about Sequoia, you mentioned that the ZFS compression ratio was 1.7 and here you're at 1.5. Is that just due to a change in workload, or is there a configuration change that has affected it? Or?
So that average is across all of our file systems, right? So we've got 9 of them, and they're all slightly different. Some are up in the 1.7, some are down in the 1.3. It kind of varies, right?
Okay.
So yeah, and it depends too, if you look at individual OSTs throughout the file system, they all vary as well. Some things are highly compressible, some are not, right? But yeah. Other questions, comments? I think I'm the only thing standing between us and beer, so I don't want to do that.
Actually, it's me.
Oh, it's him, all right.
Marc Stearman, ladies and gentlemen.
All right, thank you everyone.